Hello everyone, my name is Vrat Tomer, and today I'll be helping you understand Einstein notation. This topic I kind of struggled to understand throughout the year, and that's why I picked it. There's other topics I've struggled to learn, but this one was the simplest one that I couldn't understand, so I picked this one. My goal for this video is just essentially help you out with the basics and help you prove two problems. One a simpler one, and then first we'll dive into the basics and what you should know before you should start doing these problems. Having this sheet of paper helps a lot. Professor Smallwood will give this to you when you are getting to the subject. Especially the second page, it helps a lot to understand the permutations, if they're odd or even, which is what was one of the things that I struggled to understand. And hopefully I can convey that in a proper manner and help you understand. All right, let's start with the basics. The first symbol you'll be working with is the Levi-Civity symbol. Sorry, I can't pronounce these words very well, but they're here. Where this is the symbol you'll be working with, and these are the indices that you'll be working with again. You can use different indices, for example, KLM. Eventually, you'll be using IJK in conjunction with KLM because you have different problems that require a lot more of the symbols. And the way this is arranged will represent three numbers. It can either be 1, -1, or 0. Again, 1, -1, 0 aren't I, J, and K. The way they are arranged will tell you if they're 1, -1, or 0. So the way we can tell it's 1, it's if it's a kind of a simple order. By the way, I replaced the 1, 2, and 3 with I, J, and K because it's easier to understand that way. So this is I, this is J, and this is K. And if it changes, if the order goes clockwise like this at the bottom, it is a positive 1. And so a -1 would be called cyclic. I can't pronounce that. Where if it's going anti-clockwise, it would be minus, as opposed to the clockwise, it would be +1, and anti-clockwise would be -1. Repeated indices, if you have, say, example, I, J, that will just tell you that it's a 0. One thing I did forget was another way of realizing how it's a properly ordered cycle, meaning it's just 1, the IJK. You can use this technique I found. I only make this because I found this to be the hardest step, is understanding when it's a -1 or when it's a +1. So just write it out: 1, 2, 3, 1, 2, 3, 1, 2, 3, and then you first circle the first 3 letters, or IJK. That will be your first permutation, 1, 2, 3 in the blue. Then you leave the first number alone, then you circle the second set, which is 2, 3, and 1, which is shown here in the red. 2, 3, and 1 would again be a +1 cycle, and it's shown here at the IJK as well. And then you circle 3, 1, and 2, which is another cycle of the positive. Just another technique you can use to see if it's a anti-cyclic cycle or a positive cycle. So one cool thing about the Einstein notation is that you can, besides it helps you improve, you can easily take something that is large and compact it into something small. For example, where we have this function, or whatever it may be, a11 y1 plus a12 y2 etc. equaling c1, we can write this as a1j, because the second indices is what's changing, and yj equals c1. So what repeated indices essentially means is that there's a summation. It means that you sum over the range of that index. For example, what this essentially says is there's this invisible summation sign here, and that is j. This is invisible. I'm not supposed to see this, where essentially it adds up all the j's together, and hence it gives you the C1. And the last part for the setup is the chronicle delta. We need to familiarize ourselves with the symbol of chronicle delta and how it's used. So this is what the symbol looks like, if I can draw it right. And where, again, these indices are arbitrary. This is the example of me showing you how it works. The key thing you need to know is that a chronicle delta can only be used once. For example, if A goes into AJ goes into chronicle delta JM, the summation happens, correct? So after the summation, the J goes away and you have AM. Let's say another example would be BL. So after this is done, this is no more. You can't use you can't use any of these to, you can't use this one for any of these. So BL, we find BL. So we find just the L subscript. It matches with this one and this one. We can use either one. So if we use this one, it would be BL. So the BL, these are two subscripts that are the same, so there's a summation happening there. And then you have BI, and again this goes away. Again, CM, IM, the CMs these are summed up, and then what you have left over is a CI. And again, this is gone. You can't use it anymore. You can only use it once. Okay, now since we have all the basics down, let's try and do a problem. This problem I'm going to do, it's going to be the vector triple product. It's not the hardest problem. It's pretty in between. It's a problem that I'm sure you'll have on an exam, and hopefully it helps you out. Let's see. Okay, so we have the vector triple product. When doing Einstein notation, just be careful how you use your brackets and notations. Just don't throw brackets and notation at everything. Just put it in a way that it will help you out. So first we write this as the ith component. This vector is the ith component of this. And then we can write this cross product as a Levi-Civitani symbol, where it's epsilon ijk, where the A is J, not I, and the cross product of B and C is the K component. And this cross product then can also be written as epsilon KLM. Now we have two epsilons. We can rearrange them and put them together, but we also have to understand that this is summing over the K, where this is summing over I. So in this case, I chose to pick K, so I have to change this in a way where K comes first, whereas K is being summed up. So again, you can use this little technique where you write IJK. The blue would be the IJK, the red would be JKI, and the green would be KIJ, which still equals 1. and which I wrote here, Kij. The green represents that it's 1. And now you have put these together, and this shows that summing over one index of a product of a epsilon symbol can be written as a Kronecker delta, where we can write these as Kronecker deltas by matching these symbols. So the way I do it is, the way I remember is the bottom part, the I goes with the N, so I will go with L, and J will go with M, I, L, J, M right here. And now we use the top, now we go to the top, essentially flipping it on the top. The I will go with IM, and the J will go with JL. Where is JL and IM? Actually, the top goes second and the bottom goes first, and these are subtracted. Hopefully that was shown correctly. Oh, thirsty. And now we distribute these, but first we want to make sure, we want to first try keep a index. So not, if you change all these index, it won't really help you at all. So I kept I and J. So I'm going to leave the index of J alone and then distribute these to its respective Kronecker deltas. So BL will go to the Kronecker delta IL. The L's are summed up again, and that will give you a BI as shown here. The CM will go into the JM, where the M is summed up, and it will give you a CJ. Now moving on to this one, again we're leaving the AJ alone for just to keep a consistent indices. BL will be summed up to be BJ, and then CM, the M will be summed up to be CI. Okay, now we write these in proper order, where the J's go together, the J's go together, and the I's are left out. And then these are then can be written as this, and this is the ith component of the triple product, vector triple product. And remember that. Keep I, yeah. Hello everyone, my name is Rod Tomer, and this is my blah 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 blah. Damn it. Was I not recording?